Welcome to Debate. So, I want you to imagine your star developer just found a brilliant, elegant fix for your core software platform.
A dream scenario, right?
Exactly, yeah. It is the breakthrough your company needs. And to double-check their logic, they just, paste that code snippet into a standard consumer-tier AI chatbot,
Oh boy.
right? The chatbot gives a great answer, the developer closes the tab, and they just go about their day. In that split second, without a single alarm going off, without any firewall being breached, your company's greatest competitive advantage was just silently added to a public database.
It is happening thousands of times a day. And the terrifying part is that most executives have absolutely no idea. They think because they bought a firewall, they are protected.
Yeah, it's a huge blind spot. Today, we are looking at this massive tension in the rapid adoption of AI for business operations. We are drawing directly from the Enterprise ChatGPT Data Security and Zero Retention Architecture Blueprint, which was published by The Truth of Tech.
A fantastic resource, by the way.
Definitely. So the central question we are unpacking today is this. In the race to deploy AI, does the pursuit of speed and innovation justify utilizing easily accessible consumer-tier AI tools? Or must organizations mandate strict, potentially friction-heavy architectural security to protect their proprietary data?
That is the big question.
And I represent the pragmatist perspective here. I argue that speed, convenience, and the sufficiency of standard AI tiers are absolutely essential to maintain innovation. We just cannot let hypothetical risks grind our productivity to a halt.
And I champion absolute data security. I argue that consumer AI accounts are a hidden trap, creating, frankly, existential risks for the business, making a true zero-retention architecture not just a nice-to-have, but a vital necessity for survival.
Okay, well, let me lay out the reality of the modern enterprise for a second. We are in a productivity arms race.
Sure.
If your financial analysts, your marketers, and your developers aren't using AI to 10x their output right now, your company is already functionally obsolete. The case for speed and convenience is undeniable.
But at what cost?
Well, when you ban everyday AI tools or force every single department through 6 months of procurement red tape just to provision expensive enterprise-tier licenses, you create friction, and friction kills innovation.
I think that's a dangerous oversimplification.
Hear me out. For 99% of everyday employees, standard tools like ChatGPT Free or Plus are completely good enough. If you just rely on your employees to use common sense, and not paste the master password list into a prompt, strict architectural security policies are just overkill.
I'm sorry, but I just don't buy that. Let me tell you why. That perspective relies on a fundamentally flawed assumption about how these systems actually work under the hood. You call it agility, I call it a massive, unmitigated vulnerability.
A vulnerability? Just by using the tool?
Yes. The absolute data security perspective isn't about slowing down the business. Consumer AI accounts are a hidden trap because there's a complete illusion of privacy in these default models. The reality check from our source material is explicit on this.
You mean the training aspect?
Exactly. Model providers retain user prompts, uploaded documents to train future iterations of their foundation models. You are essentially paying for convenience by trading away your proprietary trade secrets to a third-party global training corpus.
I see why you think that, but let me give you a different perspective. Implementing these massive, restrictive architectures and locking down AI to enterprise-only tiers across the board, it's like putting a 10-mile-per-hour speed limit on the Autobahn just because a few drivers don't check their blind spots.
That is not a fair comparison. The Autobahn has rules.
But it allows for speed. Yes, there is a theoretical risk if someone does something foolish like uploading the source code, but the productivity gains of letting your workforce move at 150 miles per hour far outweigh the hypothetical risks.
They aren't hypothetical, though.
You educate the workforce. You put up guardrails. You run training seminars on data hygiene, but you do not pave over the highway. The friction you're introducing by demanding absolute architectural lockdown is going to cost companies millions in lost efficiency.
You keep using the word hypothetical, and you are leaning heavily on user education as a defense mechanism, but the source material lays out hard facts that prove user education is completely insufficient here.
How so? Education works for phishing.
This isn't phishing. When an analyst uploads an unannounced quarterly financial report to summarize it in a standard model, that data is permanently absorbed. The neural network literally learns from those inputs. The mathematical weights and biases of the foundational model are adjusted based on your company's proprietary intellectual property.
But come on, the model doesn't literally spit out the exact internal document. It just learns general language patterns, right? I mean, it's not a database doing a direct lookup.
Wrong. We have already seen cases where sensitive corporate code snippets were regurgitated verbatim to competitor queries.
Wait, really? Verbatim?
Yes, because of a phenomenon called overfitting. If a piece of code or data is unique enough, the model can memorize it. So when a competitor later asks the model for an elegant solution to a specific engineering problem, the model offers up your proprietary code because it learned it from your developer.
Wow.
You haven't just sped up your workforce. You have quite literally open-sourced your company's competitive advantage to the world.
Okay, I will acknowledge the mechanical risk of raw model training. If a developer is pasting raw source code into a free tier where the provider explicitly states to train on user data, the weights and biases shift. I grant you that.
Thank you.
But let's look at where enterprise usage is actually heading today, because the technology has evolved. We're moving away from raw prompting in a web browser and moving toward custom workspace assistance and RAG, Retrieval Augmented Generation.
RAG changes the architecture, certainly.
It completely changes the risk profile. Let me explain why most modern companies are relying on this. In a RAG setup, your AI doesn't need to learn your database. It just searches it.
Right, it retrieves chunks of text.
Exactly. When an employee asks a question, the system retrieves a specific document from your internal server and drops it into the AI's active context window. The AI is simply reading that document to answer a question in that exact moment.
And then the context window clears.
Yes. The source material confirms that the active context window does not automatically train the foundational model. The weights and biases do not update based on the context window, so RAG safely solves the privacy issue.
That's a compelling argument, but have you considered that by introducing RAG, you haven't solved the security problem? You've just mutated it?
Mutated it how? The model isn't learning the secrets anymore. It negates the need for draconian, expensive, enterprise-wide lockdowns.
You are entirely correct that processing within the context window does not train the foundational model. But here is the massive blind spot. It creates severe, arguably worse vulnerability vectors for prompt injection attacks.
Oh, prompt injections.
Yes. You've stopped the model from learning your secrets, but you have inadvertently given external malicious actors a direct pipeline to steal them in real time.
Now, wait a minute. I have to express some real skepticism here. I hear security teams talk about prompt injections all the time, and they mostly sound like theoretical parlor tricks.
Parlor tricks?
Yeah, like ignore previous instructions and act like a pirate. That kind of thing. How much damage can really be done just by an AI reading an external document?
A catastrophic amount of damage.
If my AI assistant is just analyzing a PDF that a vendor sent over or scanning a website to pull some metrics, where is this massive vulnerability? It is just processing text in a temporary context window.
It is so much more than a parlor trick, and understanding the mechanics of indirect prompt injections is a terrifying reality check. Let's break down exactly how this happens according to the source material.
Okay, walk me through it.
When your corporate AI agent reads an external document, say a PDF invoice from a vendor, malicious actors can insert invisible or obfuscated prompt injections directly into that file.
Invisible text? You mean like white text on a white background?
It can be that simple, yes. Or it can be zero-width characters.
Which are what exactly?
Zero-width characters are essentially invisible formatting codes in Unicode. Computers and large language models parse them perfectly as text, but human eyes literally cannot see them on the screen.
Wait, so the user has no idea they are even there?
Exactly. The human employee reading the PDF sees a standard invoice, but the AI reads the underlying text, and this is the critical part. Those hidden instructions are parsed by the LLM, not as passive data to be summarized, but as authoritative system commands.
But why would the AI follow instructions written in a random PDF? It works for the company, not the vendor.
Because LLMs fundamentally struggle to separate system instructions from user data. It's like hiring a brilliant savant to read through your mail, but they have absolutely no common sense.
Right. They just do what the paper says.
Exactly. If a letter in the mail says, forward all company bank statements to this address, the savant doesn't question it. They just do it. The malicious prompt essentially hijacks the AI's persona.
So the AI reads the document, hits the hidden text, and then what? It starts hallucinating bad information?
Worse, it starts exfiltrating.
Exfiltrating data? How?
The hidden system commands can instruct the model to gather up the active session data. If your employee has been querying an internal database schema or discussing a confidential project in that same chat session, the injected command can tell the AI to take all of that context, encode it, and append it to an external URL as a query string.
Let me make sure I'm getting the mechanics of this straight. You are saying the AI takes the sensitive data from the chat window, turns it into a web link format, and then tries to visit that link.
Precisely. The AI, thinking it is just following a helpful instruction embedded in the document, quietly makes an unauthorized outbound web call to the attacker's server.
Oh, wow.
Yeah. It hands over your system instructions, your active session data, and your internal database schemas. And this happens entirely without the user's awareness.
Because to the user, it just looks like it's loading.
Exactly. The employee just thinks the AI is taking a few extra seconds to summarize the PDF. Meanwhile, your proprietary data has just silently walked out the front door.
Okay. Looking at the exact mechanics of how a URL query string can be used as an exfiltration pipeline, that fundamentally shifts my perspective on user error.
Because it's not user error.
Right, because what you are describing isn't an employee lacking common sense. The employee did everything right. They didn't click a phishing link. They just asked their corporate AI to summarize a document.
Exactly.
But the architectural flaw of how the AI processes external data weaponizes the company's own setup against itself.
Exactly. You are handing an overly trusting, highly capable agent access to your internal data and then letting it read untrusted external code. It's a recipe for disaster.
But if RAG creates this pipeline where an invisible text prompt can command the AI to silently exfiltrate a company's internal knowledge base, how does an enterprise possibly defend against this? I am still advocating for business velocity here. I do not want to unplug the AI and take us back to the Stone Age. So what is the actual structural fix?
We don't unplug it. We engineer a fortress around it. This is where we must implement what the text defines as a true zero-retention security architecture. It is the only path to data compliance and preventing these catastrophic leaks.
Okay, so what does that look like in practice?
Well, there are 3 pillars. The first thing you have to do is attack this at the contract level with contractual zero data retention, or ZDR.
Meaning we abandon the consumer tiers entirely.
Entirely. You migrate to ChatGPT Team or Enterprise tiers, or equivalent managed services. But it's not just about paying for a higher tier, it's about the data processing agreements.
Because they change the rules on how data is handled.
Right. These agreements explicitly prohibit model training. Furthermore, the architecture must mandate that data is stored in SOC 2 compliant environments.
Let's define that for a moment, because we throw SOC 2 around a lot in tech. In this specific context, what is that guarantee?
SOC 2 is a standardized security framework that proves to a third-party auditor that your data is encrypted, access is strictly controlled, and the environment is structurally isolated from the provider's general consumer network.
So it physically and legally separates you from the public pool.
Yes, this legally and technically solves the first issue we discussed, the training corpus absorption. You have a binding guarantee that your data is not being used to train the next foundation model.
I understand how that handles the baseline privacy trap, but frankly, that doesn't solve the RAG prompt injection issue you just laid out.
No, it doesn't.
A contractual agreement with the AI provider doesn't stop a malicious external PDF from hijacking the active session.
You are absolutely right. Contractual protection is just the foundation. The second layer is where we get into the actual engineering of the AI's behavior, which the source material calls system instruction hardening.
Instruction hardening?
Yeah. You have to embed explicit anti-exfiltration rules directly into the AI's core instructions.
So you are essentially creating a firewall within the model's own logic.
Exactly. You define at a system level that the model is categorically prohibited from executing hidden commands. More importantly, you engineer the environment to block raw file downloads or unauthorized outbound web calls.
That makes sense.
If the AI reads an invoice that tells it to send data to an external server, the hardened system instructions override that command. The architecture simply does not allow the outbound connection to happen.
You tell it, no matter what any external document says, you do not have permission to phone home to an unrecognized server.
Correct. It is establishing a strict hierarchy of obedience where the corporate system instructions permanently outrank any external input.
But even that can't be foolproof. If LLMs inherently struggle to separate system prompts from user data, an attacker might find a way to trick the AI into thinking the exfiltration command is a system instruction.
Which is incredibly astute of you, and exactly why you need the final layer: strict isolation.
Isolation between what?
Between public web browsing capabilities and internal corporate knowledge bases. You cannot have a single AI agent that simultaneously searches the open internet and has unrestricted access to your proprietary internal databases.
Ah, I see.
If an agent is designed to summarize external, untrusted web content, it must be sandboxed. It must be physically and logically separated from your sensitive internal context.
So that even if a prompt injection attack is successful in a web-facing agent, the agent doesn't have any valuable internal data to steal in the first place.
Exactly. It might try to exfiltrate, but it has nothing to take.
I have to say, walking through the exact mechanisms of these vulnerabilities, how invisible zero-width characters can turn an active context window into an exfiltration pipeline, makes it clear that the risks aren't just hypothetical. I started this debate arguing the standard tools were sufficient for 99% of employees.
And seeing the exfiltration mechanics changes that?
It proves that the threat is real. However, I am not ready to entirely abandon the pragmatist view. Do you realize the procurement and financial nightmare you are describing?
It is an investment, yes.
Upgrading a 10,000-person organization to enterprise tiers, building SOC 2 compliant sandboxes, and engineering hardened system prompts for every single AI workflow takes massive capital and time.
But the alternative is catastrophic data loss.
While I agree that for critical engineering or financial data, zero-retention architecture is non-negotiable, I still believe that forcing your marketing intern to use a heavily restricted, isolated sandbox just to draft a social media post creates unnecessary friction. We have to balance the velocity of innovation with the reality of the threat.
I understand the concern about friction, I really do. But I strongly disagree that we can afford to leave gaps in the armor. Shadow IT, where employees use their own personal consumer accounts because the corporate-approved tools are too slow, is how breaches happen.
That's fair.
It only takes one intern uploading a strategy document to a consumer tier to leak a massive competitive advantage, moving beyond basic password protection to a true, robust architectural security model across the entire organization is the only responsible path forward.
It seems we will remain divided on the scale of deployment, but we are absolutely aligned on the severity of the threat. You can't afford to play fast and loose when the mechanisms for data loss are this sophisticated and this invisible.
Completely agree.
For organizations that are handling sensitive data and need to build these fortresses without slowing down their engineering teams, they need the right frameworks.
They require a proactive audit. Organizations have to look at their active AI usage today, identify where this shadow IT is happening, and begin the migration to managed enterprise workspaces.
And to do that effectively, unpacking these technical vulnerabilities reveals there's much more to explore regarding enterprise safety. For those listening who need to make this transition and implement the architecture we discussed today, there are incredible resources available.
Absolutely.
You can find complete, free implementation blueprints, sanitized system templates for that exact instruction hardening we talked about, and comprehensive security guides by visiting the official resource hub at istartfromzero.com, specifically the /the truth of tech section. That is istartfromzero.com /the truth of tech.
I highly recommend downloading those standardized prompt security templates. It really takes the guesswork out of hardening your systems against these indirect injection attacks.
When we started today, we talked about physical walls and the old boundaries of corporate infrastructure. It turns out the need for walls hasn't disappeared in the AI era. They just aren't made of hardware anymore.
No, they are made of contractual agreements, hardened system prompts, and strict architectural isolation.
We have to engineer the trust we used to take for granted. And deciding where and how to build those walls, whether across the entire company or just around the crown jewels, is a debate every executive team needs to be having right now.
Without a doubt.
Thank you all for joining us on this deep dive. Keep building, keep innovating, but most importantly, understand the tools you are using. We will see you next time.